Welcome to qnawire.
In this question, we are given two blocks connected with a pulley via a string. The mass of this block is m1 and the mass of this other block is m2. The value of m1 and m2 is also given to us. M1 is 5 kg and m2 is 2 kg. On these two blocks, F and F force is acting downward. The value of F force is also given to us, that is 1 Newton. We have to find in the first part the acceleration of both the blocks. In second part, we have to find if this string cuts suddenly, then we have to describe the motion of this first block M1. Okay, so let's say the acceleration of the M1 block is A, that will be downward. Why it will be downward? Because the M1 mass is more than M2 mass, and as on both the blocks the same force is F is acting, so we can just say that this M1 block is going to move downward with the acceleration A, and M2 block is going to move upward with the same acceleration A, as the string is inextensible. On M1 block, the force due to gravity will be acting downward, which will be M1g, and a tension force will be acting in the upward direction, that will be T. On M2 block, again its force due to gravity will be acting downward, that will be M2g. A tension force will be acting in the upward direction, which is T, and on both the blocks F force is as it is acting. So if I draw the free body diagram of M1 block, then we can replace this M1 block with a point. On this block, downward force is F plus M1g, and upward force is the tension force T. Under these forces, the M1 block is moving downward with acceleration A. So then by applying Newton's second law in the particular downward direction, we can write that the net force on this M1 block, that is F plus M1g minus T, that has to be equal to M1A. So let's say this is my equation number 1. For second block, I can again draw the free body diagram. So FBD of M2, so we can replace this M2 mass by a point. The tension force in this case is acting in the upward direction, and the M2g and the F force is acting in the downward direction, and in this case the block as a whole is moving upward with the acceleration of A. So by applying Newton's second law in the upward direction, we can write that the net force in the upward direction, which is T minus M2g plus F, is going to be equal to M2 times A. So let's say this is my equation number 2. So we can simplify this second equation and we can write T minus M2g minus F is equal to M2 times A. So this is actually the second equation. So now on adding first and second equation, we can write by adding 1 and 2, we will get if I add 1 and 2, then on the left hand side you can see F force will be cancelled as it is having plus and minus F. T force is also going to cancel, so we will have on the left hand side M1g minus M2g. On the right hand side we will have M1a plus M2a, which I can write as M1 plus M2 into A. So from here I can write that A, the acceleration of the blocks, is going to be M1 minus M2 g by M1 plus M2. Okay, now we can put the values of M1 and M2 as it is given, that M1 is 5 kg, so 5 minus M2 is 2 kg, divided by M1 is 5 plus 2, and G we can take it as 9.8 meter per second square. So on simplifying this, we will get A equal to 4.2 meter per second square. So this is the answer for part A. In part B, we have to see that if the string breaks suddenly, what will be the motion of the block M1. So suppose this is the block M1. On this block, the downward force is F and M1G. In the upward direction, the force was tension force, but due to breaking of the string, the tension force on the string will become 0. So then the net force on the block is, let's write in this way: due to breaking of string, the net force on M1 is F plus M1G downward. Then the acceleration of the block A, or let's say A1, that will be F plus M1G by M1. So by putting the values, we will get A1 equals to F is 1, M1 is 5 kg, G I can take 9.8 divided by M1 is again 5 kg. So on simplifying this, we will get A1 equal to 10 meter per second square. So thus we can just conclude that this first block after the breaking of the string will keep moving downward with an acceleration of approximately 10 meter per second square.